Hello, sir. Jayaraman, sir.
Yes, sir.
Can you hear me, sir?
I can hear you, sir. Sir.
Yes, sir. Your voice is very feeble, sir. Can you be a bit louder, sir?
Is it better now?
Yeah, yes, sir.
Okay.
Fine, sir. Maria, ma'am, we can get started, ma'am.
Yes, sir. Okay, we'll start now. A very warm good evening to one and all present here. Welcome to day 4 of the ATAL 6-day Faculty Development Program on High Performance Computing, Transforming Research Through Advanced Technology. I'm very happy to welcome Mr. Jayaraman. Mr. Jayaraman is a seasoned IT executive and a highly collaborative and strategic leader renowned for building and leading high-performance cross-functional teams. With a proven track record of delivering innovative and transformative solutions, he has consistently enabled organizations to achieve significant growth and market expansion. Mr. Jayaraman possesses expertise in global delivery management, product development, mobility, cloud analytics, social and digital transformation services. Currently, he serves as the head of IT at Myras Management Limited, UAE, a prominent organization known for its forward-thinking approach and commitment to excellence. He will enlighten us on the topic visualization techniques for HPC data. On behalf of JPR Institute of Technology, I extend a very warm welcome to you, sir. I now hand over the session to you. Thank you.
Thank you, Mariam, ma'am, for the wonderful introduction, and thank you, Venkatraman sir, for inviting me for this session. Just a second, let me share my screen. Let me know once you see my screen.
Yes, sir. We are able to see the screen, sir.
Perfect. So you are seeing it in the presentation mode, right?
Yes, sir. Yes, sir. Yes, sir.
Perfect. Thank you. Thank you, sir. So good evening, everyone, and thank you for joining this session on data visualization. My name is Jayaraman Kumarapan, and I'm currently based in Dubai and have the privilege of working for Myras Management Limited. Over the years, I have gained extensive experience in utilizing data visualization to communicate complex ideas effectively. In this session, we will explore the importance of the data visualization, common pitfalls, and strategies to create a meaningful visuals that drive understanding and engagement. So let's take a look at the key learning objectives for today's session. By the end of this session, you will have gained insights to 3 critical areas, which is fundamental concepts of visualization. First, we will focus on the basics of data visualization, and you will learn the core principles that define effective visual communication. This includes understanding the importance of visualization in the data analysis and improving data literacy by presenting information visual in clear and engaging way. Audience-centric design. Next, we will explore how to design visualizations that resonate with specific audiences. It's not just about presenting the data. It's about tailoring your message to meet the needs and expectations of your viewers. we will cover how to assess your audience demographics and preferences so your visuals align with their understanding and goals. And the last part is data preparation skills. Finally, we will dive into the foundation of any great visualization data preparation. You will learn essential techniques for assessing the quality and relevance of your data. Together, these objectives will provide you with the skills needed to not only to create compelling visuals, but also ensuring that the process behind them is solid and audience focused. The section 1, the importance of the visualization, data visualization. These days, the data is more valuable than gold. Every device you use, from your laptop to your smartphone, collects data constantly. For instance, if you search for a holiday destination on your phone, you will soon start seeing the ads for flights, hotels, and travel deals on your browser and apps wherever you go, whatever you open. Sometimes you feel like someone is hearing your conversations and then suggesting the ads based on the conversation you had. It's true. If you're not disabling your mic, there are some phones coming up with the options now. You disable your mic now. If you're not disabling your mic, there is a chance the applications might hear you whenever you are having a conversation with others, and then it may give you the relevant details, or it may use the information for something else. So this data helps the companies to tailor service for our preferences. Another example is the beer and the diaper case study, which has happened in the 2016. Whenever there is a diaper sales high, the beer sales also is high. The retailers, they don't know what is the reason behind it, and then they wanted to understand. So they've seen the pattern regularly by using those small visualization techniques. They identified whoever comes to buy the diapers were all young dads. So when they are coming to buy the diapers, they're also getting the beers from the next section. So identifying that, they moved the beer section closer to the diaper section to increase the revenue, and it worked dramatically, and then they increased their sales. There is one more example which happened when I was working for a telecom company. So for example, I might take it as an you all know Tamil Nadu, and you all know Tinagar. So we wanted a target between 25 to 30 age group, whoever inside the Tinagar area during that time, for example, from 11 to 1 p.m., 11 a.m. to 1 p.m., we wanted to send one promotional offer about in the shop in the Tinagar area. So how is it possible? So we have the data from the telecom company. There is a separate data. There is a separate data from the triangulate the signals from the tower data. So these two data in the separate server, and creating a one visualization pattern, and then identifying those data, and then we did the target marketing. It has happened a long time back. Now the market has evolved so much, and they are using the data for a very minute detail to understand how they can increase the business, and how they can make the user preferences more important way. There is an you may think it intrusive as part of how companies create value in our digital world. However, The raw data alone is not useful. Like I said, it's only through visualization the data becomes understandable and actionable. Simply put, the data without visualization is like a map without directions, which is why those who can present the data effectively are in high demand. In this presentation, we will explore how data visualization helps make sense of information and drives better decisions. Understanding the overview of the data visualization, understanding the brain's role in data visualization. Imagine this, you are standing in front of a bookshelf with 3 books. You can easily pick out of the size, color, and title of each book without much effort. Now imagine that the same bookshelf has 30 books. It's still manageable to identify individual titles, though it takes a little longer. But what if the bookshelf have 300 books, or 3,000, or even 30,000, or 300,000? At some point, no matter how hard you try, your brain struggles to process all the details. That's where the charts and graphs come in. They help us make sense of data volume that our brains can't easily visualize. But the brain science behind this goes deeper. It's not just about managing a data, but also about presenting it effectively. How our brains process the data? The human brain registers visual information 60,000 times faster than the other forms of communication. It processes information in 2 ways: subconsciously, pre-attentive processing. This is like a filter. It takes a visual cues like colors, shapes, and size, forming quick conclusions in just 1 out of 10th of a second. Consciously, the attentive processing. This involves the deeper analysis and deliberative thinking. Pre-attentive process is incredibly fast and shapes our understanding before we even realize it. However, it can also mislead us if visuals aren't designed carefully. Examples of pre-attentive processing: consider the 3 charts showing the same data. The first chart uses a different color for every bar, which causes confusion because our subconscious mind starts searching for hidden meaning in the color choices. The second chart uses a uniform bar colors organized from highest to lowest, making it easier to identify the key insights. The third chart improves further by adding icons to each bar. This use of iconography leverages pre-attentive processing for even faster understanding. Listening the brain. When creating the data visualization, it's essential to consider how the brain processes visuals. Here are some best practices, like use constant colors to avoid unnecessary distractions. Order data logically, such as from highest to lowest. Incorporate icons or visuals where appropriate to enhance clarity. Avoid overloading the audience with too much detail. By understanding and leveraging the brain's pre-attentive processing power, you can create visualizations that are not only accurate, but also instantly clear and impactful. The evaluation of data visualization. The representation of data visually or data visualization has been a key tool for understanding and communicating numerical relationships for centuries. For example, ancient civilizations. Maps created over 8,000 years ago are considered the first form of data visualization. They combine scale, distance, latitude, and longitude to represent geographical and spatial relationships. If you are from India, you know our history is very long, and then we have represented the Navagragas and astrology charts way before that. So it's all visual representation. Without visual representation, we cannot identify like which which planet where and all these things. Like so, we have the visualization from the history. We started showing the data visualization to understand easily. And to start with the 17th century innovation, in 1600s, the advancements of astronomy introduced graphical methods for representing complex data. Kepler and others used these methods to plot planetary movements, showcasing the power of visual communication in science. And in the 18th century, in 1786, William Playfair revolutionized data visualization with the introduction of line and bar graphs in the commercial and political atlas. For example, he used the bar graphs to display Scotland's trade data, helping even those within the limited literacy understand complex economic patterns. He later invented the pie chart and area graphs, further transforming how data was communicated. 19th century advancements. Figures like Florence Nightingale used visualizations to drive meaningful change. Nightingale's chart made public health data accessible, influencing health policies and saving lives. Similarly, the data visualization started to guide decisions on crime, population, and financial stability. 20th century digital shift. With the rise of computing, data visualization expanded its capabilities. Technology enabled handling vast data sets like big data, introducing software tools for dynamic and complex visualizations. The last one, contemporary era. Today, data visualization is integral to understanding big data. Combining advanced technology with design, it's allow us to process and interpret information quickly and effectively. So, why does this history matter? Because data visualization is a universal form of communication. Traditional charts and graphs have stood the test of time because they work. When creating visualizations, prioritize clarity and simplicity over flashy designs. The goal is to ensure your data tells a compelling story that resonates with your audience. Significance in today's market. Now let's delve into why data visualization is so crucial in today's market. To illustrate its impact, I'll share several real-world case studies that highlights its significance. Data-driven decision-making. Effective data visualization enables organizations to make informed decisions by presenting complex data in a clear, actionable format. For instance, the Texas Rangers baseball team utilized data visualization to enhance fan experiences. By analyzing and visualizing fan engagement data, they developed strategies that increased attendance and improved overall satisfaction. Enhanced stakeholder engagement. Visualizations improve comprehension and retention, facilitating better communication with stakeholders. A notable example is GitHub's Octoverse. If you see the Octoverse report, which uses engaging charts and graphs to present data on developer activities. This approach not only informs but also captivates its audience, strengthening community engagement. Ethical data presentation. Upholding ethical standards in data visualization fosters trust and transparency. The International Consortium of Investigative Journalists ICIJ employed data visualization tools during the Panama Papers investigations to uncover complex offshore financial networks. By accurately representing intricate data, they provided clear insights into global corruption, underscoring the importance of ethical data presentation. These case studies demonstrate that data visualization is not merely a tool for analysis, but it's a vital component in decision making, stakeholder engagement, and maintaining integrity in the data-driven world. So far, I'm going in a good direction, I guess, like moving on to the section 2. As we move on to section 2, let's explore the best practices in data visualization. In this section, we will outline the key principles and techniques that ensure our visualizations are clear, engaging, and effective. Let's talk about choosing the right types of charts, the graphs of our data. While the science of how our brain processes visuals is critical, the types of charts we use should also align with our audience level of data literacy. For example, the most audience are comfortable with simple visualizations like pie charts, bar graphs, line graphs, and area graphs. These type of charts have been around for centuries and are universally understood. They are an excellent choice when presenting the data to a general audience. However, the average audience might also grasp slightly more complex charts, such as scatter plots, stake bar charts, and heat maps. These charts often require additional context or explanation, but can still be effective when the audience has more familiarity with the data being presented. On the other hand, highly analytical audience may be comfortable with advanced visualizations, such as box plots, waterfall charts, sneaky diagrams, or bubble charts. But there is a reason these charts are rarely used in commercial or general content. They often require a deeper understanding of data and might need a presenter to guide the audience. Then there are visualizations that seem multiple, sometimes simple, but can actually mislead or confuse. For instance, a circular bar or a graph might show the correct length of each bar, but its circular shape can make the data appear percentage based like a pie chart when it is not. Similarly, bubble plots can be problematic because our brains aren't good at comparing the area of size of circles. In such cases, a simple bar chart would work much better. The takeaway of this, different audiences have different levels of data literacy. If you're unsure where your audience falls on the spectrum, it's best to keep it simple and stick with charts that are universally understood. This ensures your visuals are easy to digest and your message gets across effectively. In the slides ahead, we will cover the best practices for both simple and complex visualizations, so we will know how to use them effectively for any type of audience. Now, let's explore how to create effective charts and graphs. To ensure our visualizations are impactful, there are 3 key principles to focus on, supported by real-world examples. Importance of visually hierarchy. So establishing a clear visual hierarchy is essential for guiding your or our audience attention. For example, during 2008 financial crisis, the New York Times created a compelling interactive visualization that highlighted the flow of federal bailout funds by using size, color, and placement. They directed viewers' focus to the most critical data points, helping readers quickly grasp the scale and the distribution of the bailout. Consistency in design elements. Consistency across fonts, colors, and styles ensure clarity. A great example is Spotify's Wrapped campaign. The, the yearly summary uses consistent design elements, including bold, colorful charts and the familiar fonts across all user interfaces and marketing materials. This consistency reinforces brand identity while ensuring users can easily interpret their personal music data. Feedback and iteration. Feedback is a crucial for refining visualizations. For instance, Airbnb's design team relies heavily on user testing for their data dashboards. Through multiple iterations based on feedback, they have created dashboards that are both visually appealing and easy for hosts to use. This process ensures the visualizations effectively communicate vital booking and pricing information to their audience. By applying these principles, visual hierarchy, consistent design, and a feedback, along with lessons from these case studies, we can create charts and graphs that are not only visually appealing, but also highly effective in delivering our message. Tools and techniques for data visualization. So I have created one section for the tools, which is used for a free and the paid one. This is just to overall introduction for the tools, and then we will go into the deep dive into the tools. Let's talk about the tools. Diverse tool selections, like picking the right tool, like choosing the right mode of transport. If you are just going to the corner shop, we don't need a Ferrari. The same applies to the visualization tools. Tableau. This tool is like a kind of a Tesla of data visualization, powerful, sleek, and user friendly. Tableau has been famously used by Spotify to create visual dashboards that shows users their wrapped data, breaking down their top artists, songs, and listening habits. Imagine realizing we have listened to 5,000 hours of Taylor Swift. Now the data story was sharing. And D3.js, on the other hand, D3.js is like assembling our own vehicle from scratch. It's a powerful and customizable, but requires technical capabilities to fix and create the visuals. The Guardian once used D3.js to create an interactive map for election results. It was a hit until readers discovered they could make the map dance by hovering their cursor over certain spots. But accidental engagement, but it worked. Best practices for clarity. Now, onto the techniques. Remember, good visualization is about making complex things simple, like turning our like a messy fridge into the Michelin star display. Use the right chart type. Imagine trying to explain pizza consumption trends using a pie chart. It's perfect because it's literally a pie. But if you are showing how toppings have changed over time, a line chart would be better choice and for less confusing. Use color wisely. For example, like McDonald's dashboards. Track the speed of drive-through services with green, yellow, and red indicators. A spike in red, someone probably ordered 100 burgers during the peak hours. There was one funny case study. One of my favorite also, like it's a Netflix internal data team. Whenever they were checking the data pattern, and then they found out whenever there is a new season of any hit series like Stranger Things or Drops, the line of graph showed the internal bandwidth of usage at Netflix office spiking dramatically. Turns out that later they found out employees were binge watching at work. The company loved it, but the visualization made it clear that productivity was well compromised because they are binge watching the movie internally or series internally. By combining the right tools and adding creativity, and clarity, you can turn dry data into engaging stories that stick with our audience. This one is a very important factor. It's being a data fiduciary. So we covered how to identify the right data sets, charts, and everything. But let's discuss the another crucial aspects of data visualization, which is our role as a data fiduciary. As a data fiduciary, your responsibility goes beyond simply presenting the data. It's about ensuring that our visualizations are not only easy to understand, but also provide the most accurate representation of the information. With big data being such an integral part of our lives today, charts and graphs have become ubiquitous. Organizations across industry use visualizations to engage their audiences, but sometimes this is done to a fault. Mistakes in data visualization, whether we are doing it intentionally or not intentionally, at the best, these mistakes can embrace a brand or an organization. At worst, they can lead to false conclusions, spread misinformation, and even have real-life consequences. There were two instances like we can relate. One is Satyam Computers. They were misrepresenting the data, financial data, and which lead them to the company got crashed and they sold all their IT sectors to Mahindra, and some of the real estates wherever they invested, everything is gone. And another recent example is one edutech company. I'm not able to recollect the name, but I think that company also misrepresented the data. How they misrepresented the data is like they have a subscription model for education technology, but they have covered like 3 years their subscription as 1 year revenue. They showed it into the investors, and then they have created a lot of investments based on the data presented to the investors. And later they identified that data was misrepresented. intentionally, and then the company got into a trust. So it's like the being a data fiduciary. Like if someone asks us to do or malpractice with the data and show the data, misrepresenting to the any company or legal or investors or even inside audit, we have to be ensure that our hands are clean, and then we should not engage in any misrepresentation of data, because that will lead to a lot of other problems, knowingly or unknowingly. We will not know when the day will come. And like I said, there are many instances like where manipulated graphs have exaggerated product benefits, or leading to customer distress, or like similarly skewed like health data visualizations. Even like you can take Erwa Martinat during the during the pandemic as confusion to like some of the panic in some communities. They use that panics to create a visual map, like these communities are in danger, and they need the medicines quickly, and all these things. Like there are a lot of graphs which was showing like our in India the medicines were not reached in time, or some areas where they reached in like in time. So all these things, like some of the misrepresentations, it causes a lot of issues socially and economically. So to coming to the point, always highlight the importance of ethical data management. So we have to focus on the accuracy, presenting the data honestly without manipulation. Second, clarity, ensuring the audience or our boss or manager or whoever you are representing can understand the visualization without any confusion. And respect, acknowledging the privacy and rights of individual whose data you handle. Like you may have a privilege to see some of one of your colleagues' email, and you may not spread the whatever you seen in the email. Like you may learn about some new promotion or demotion or whatever it is. Like you should not use the data for our own benefit or others' benefit. So in this next slides, we'll discuss the most common data visualization mistakes that we can recognize and avoid them, ensuring that the visualization fosters trust and accountability. So we are moving into section 3, the data visualization mistakes to avoid. We will look into some of the common pitfalls that can undermine the effectiveness of our visuals, and how we can steer clear of them. Whether we are creating a simple bar chart or an interactive dashboard, avoiding these mistakes will help ensure our visualizations are clear, accurate, and impactful. So we'll discuss about prioritizing aesthetics over clarity, and misusing scales, and over manipulating visuals. So these are the common mistakes: prioritizing aesthetics over the clarity. One of the biggest mistakes is focusing on too much on making visuals to look attractive at the expense of clarity. For example, think of a pie chart with 10 different slices, each in bold, contrasting color. While it might look visually interesting, but it becomes difficult to intercept or interpret. Instead, limit the number of segments and use a clean color palette to make the chart easier to understand. Remember, the goal is to communicate information effectively, not to impress with the style. Always prioritize simplicity and clarity. The second, inconsistent, inconsistent scale usage. Another common issue is using inconsistent or misleading scales. For instance, if a bar chart starts with the y-axis at 50 instead of 0, it can exaggerate the differences between the bars. A famous real-world example of this in some election data charts, where the differences between the candidate votes were manipulated by changing the axis range. This can mislead the voters and harm the credibility. Always, we have to use the uniform scales and clearly label any deviations to provide accurate context. The third, overcomplicating visualizations. Sometimes we try to show too much in one chart. It's cluttered. For example, like imagine a bubble chart that includes the data for income, age, and the hours they worked, and the job categories, all differential by size, like position and color. While technically accurate, such a chart often leaves the receiver confused because it demands too much effort to interpret. A simpler approach, like using a bar chart or a line graph for individual dimensions, would be far more effective at conveying the key message. By avoiding these common mistakes and learning from examples like these, we can ensure our visualizations are clear, accurate, and effective. This way, our audience can focus on the message behind the data, not to trying to break their head and figure out what is that chart itself. Okay, so we are going to deep dive into that manipulating the axis part because it is very important. When we manipulate the axis in data visualization, whether intentionally or not, we can significantly distort the message we are trying to convey. Let's explore a few consequences and learn how to avoid them. Consequences of misleading access. Misleading access manipulation distorts how viewers perceive the data trends, often leading to incorrect conclusions. This can erode, the trust, the work, or even our organization. Case study. A popular example involves a well-known beverage company. They presented a bar chart showing sales growth, but the y-axis started at 90 instead of 0, making a modest 5% growth appear as a dramatic spike. Viewers were misled into thinking the company had achieved substantial growth, which later caused a backslash when the real numbers came into light. This undermined the company's credibility, and they faced a lot of accusations later. The second point, the techniques to ensure accuracy. To maintain a trust and present data ethically. Always start access at 0 when dealing with quantities or percentages, unless there is a valid reason to do otherwise. Use consistent scales across similar charts to enable accurate comparisons. Include all relevant data points to provide a complete picture. For example, an investment firm used 2 line graphs to showcase stock performance. One graph manipulated the y-axis, making the stock's increase seem more dramatic compared to another company's growth. After correcting the axis and using the consistent scales, the data showed that both the stocks had performed similarly. This adjustment helped the firm avoid the accusations of misrepresentation. I hope everyone follow this, and then maybe whenever you are receiving an email from someone and showing the graph, you will be looking at the axis to ensure that they are following or they are not manipulating. Okay, the next one, forcing your audience to do the math. So one of the most common mistakes in data visualization is forcing our audience or a boss or a client or a management to do the math. So we can discuss how to avoid this. The first one is cognitive load considerations. So engaging our audience in mental calculation increases their cognitive load. When viewers have to perform math to understand our visualization, it becomes a distraction. This added effort hinders their the ability to retain information, because like most of the people, they have that the continuous memory for 20 seconds or 40 seconds. After that, they lose that thing, and then they'll move on to the next. They may not even be able to focus on what the numbers are represented. Retain information and the clarity of our intended message. Like imagine showing a quarterly sales data in a percentages without providing the actual numbers. The audience might struggle to calculate the exact sales figures, losing focus on the insight, what we are trying to convey. And this may work like in the opposite way. I'm saying, like if you want to confuse somebody and you don't want to show them the actual data, you can do that with, but obviously we'll end up in trouble later. But to manage the time, we can do that. And self-explanatory visuals, effective visualizations, like kind of a self-explanatory. The audience or the receiver should immediately grasp the key insights without having to perform mental arithmetic. The goal is to present data in a way that eliminates the confusion or extra effort. So, like we can say we can take example from one of the well-known consumer survey once presented feedback in a complex pie chart with an ambiguous percentage. The audience found it hard to interpret, leading to misinformed decisions. Replacing it with a simple bar chart resolves the issue. The third is simplified data representation. So to avoid this pitfall, always simplify our data. When you are representing, use a clear annotations, labels, and chart types that directly convey the insights. Highlight the most important numbers or trends So the viewers don't need to interpret or calculate anything themselves. Example, instead of showing the line graph with the percentages of market share, we can annotate it with a specific value at a key points to make it more intuitive. Like a kind of a fun fact, when there was an international conference when one student was presenting from one of the UAE university. The presentation have a lot of data, and he confused everyone like in the conference. Like they were struggled to ask questions to him, and finally they engaged in a different way. Like they asked about a lot of research related questions to him, and then they got him, and then they, he cleverly designed that presentation with ample of data and the graphs and a lot of colorful charts and all these things like even the mean square error, the root mean square error, like the root mean square error was high and then the mean square error was low. Like how come that's possible? Like he was trying to clearly evade the situation, but so the people know from if you are not clear about the data, that people will try to ask questions, more questions, and it will become a problem later. So always have a clear examples and clear simple representation, so that like it's easy and reduce the later tasks. So this is the summarize of the data visualization mistakes. It's like presenting too much information, it's like ignoring the color theory or neglecting the audience. And okay, we move into the section 4. Like we are going to discuss about some of the free tools and the major players in the data visualization tools. Luckily, there are some great online tools that offer like a premium option, like not premium, to visualize a wide array of charts and graphs that you can rely on instead. This includes Flourish, PlotDB, Plotly Chart Studio, and RawGraphs.io. I'll explain each of these options in more depth. Like my favorite free data viz tool online is like Flourish Studio. This tool, like incredibly easy to use, allows you to add simple animations to your visualizations. Let you to output code for a fully interactive data visualization and concepts directly with Canva, and provides intuitive methods for customizing any design, including the ability to upload our own brand guidelines in the paid version. So it has a free and paid version. Like free version, like we can use it to play around and understand simple visualizations we can make out of it. So if you want aim to create a like data visualizations for marketing and visual storytelling purposes, Flores is a perfect solution. And PlotDB comes in a close second hand to Flores Studio. It just easy to use and customize, but doesn't include the the custom animations like Flourish does. It is, however, one of the few online solutions that I found that has accurate Marimekko like chart like functionality. That's pretty impressive, of course, but the Flourish has a variety of chart types that PlotDB doesn't have. So, it is best to combine the two when you want to wide breadth of visualizations to choose from. Plotly is a premier platform for building, scaling, and developing data apps. While Plotly targets enterprise customers, it's a free tool. Plotly Chart Studio is available. Like if anyone looking for an online data visualization solutions that can analyze the data and the output code. I prefer Plotly for complex data visualizations like kind of a violin graphs, but think it might be too robust for the creation of simple charts and graphs. Sure, we can develop the bar charts, pie charts, and more with Plotly, but the learning curve is steep, and the customization capabilities are almost too exhaustive for a simple database. Raw graphs IO is the best used when visualizing the complex charts and graphs, especially in a Flourish and PlotDB. Don't already have those charts options in their free versions. Haven't found a tool that rivals it when it comes to the parallel coordinates graphs, for example, the drag and drop functionality of raw graphs. But the customization on raw graphs is mostly more limited than other solutions mentioned. In fact, it's best to download vectors files from raw graphs and customize them. Then you can use Adobe Illustrator for the best results. The Adobe Illustrator is a paid version, but you can create amazing visuals from the Adobe Illustrator as well. So, like I recommend you can, if anyone wanted to try, just to start with Flourish and give it a try, and you will be amazed like how the data you are trying to present and how the data visualization gives the the visual effects on the data. So the Flourish Studio, it's an exceptional tool for great visually stunning and interactive data visualizations. Like I said, like it's one of its standard features is the ability to add simple animation to charts, making our data come alive for our audience. Additionally, the Flourish integrates seamlessly with Canva. Like I said, for the enhanced design workflows and the premium version, we can even upload our own branding guidelines. This tool is perfect for creating interactive and visually appealing presentations. The Flourish Studio, what are the industries using Flourish Studio is like marketing and media and public relations. Like most of the marketing companies, they use Flourish. The medium and small scale marketing companies and big companies also sometimes uses Flourish to make the the animated charts and other things. But when it is coming to big companies, they don't do the market the marketing team. They will not design any of the marketing presentations or charts or anything. They will have the outsourced team for them to do that. And for the strengths, kind of interactive storytelling and brand integration and easy of use. I have a friend of mine who's working in a digital marketing agency, and he is using Flourish Studio to create interactive dashboards and showcasing the real-time campaign performance and all these things. And the next one is PlotDB. It's another fantastic option, like especially for users looking for accurate Marimekko charts. This tool complements Flash Studio by offering features that cater to specific type of visualizations. It's easy, user-friendly, and highly intuitive, making it an excellent choice for anyone new to data visualization. A popular use case involves like the product manager leveraging PlotDB to create a category-specific data visualizations for strategy meetings. While it lacks the animatic features like a Flourish offers, but this is specialized in the complex chart types, to make a valuable addition. This PlotDB used in most the industries are retail, e-commerce, and the strategy teams. The strengths of PlotDB is like niche visualizations and simplicity and Marimekko charts. And the retail company visualized sales across multiple product categories using Marimekko charts, helping them identifying underperforming areas to improve their resource allocation. The next one is the Plotly Chart Studio. This is again a free version and one of the powerful Plotly platform, and it's ideal for creating advanced data visualizations like violin plots and bubble charts. While the tool offers extensive, the customization options, it comes with a steeper learning curve, which might not be ideal for beginners. However, the professionals dealing with complex data sets, Plotly Chart Studio is a game changer. And data scientists often use this tool to visualize the statistical distribution in research and kind of a technical presentations. It also supports the exporting visualizations as a code, making it a powerful option for developers and researchers. The industry is using Plotly Chart Studio is like research and data science and the software development. The strengths of using Plotly Chart Studio is like advanced visualizations and the code integration and robust customization. A data science team used a Plotly to visualize the population growth trends with violin plots, helping the policymakers to make informed decisions about the urban planning. Whenever they are doing the urban planning, they use this kind of growth trends to understand like whether they have to further develop the urban development or they don't need to focus on this. And rawgraphs.io. Rawgraphs.io stands out as a kind of a unique tool for creating static and complex visualizations, especially when working with the parallel coordinate graphs. It drags and drop functionality makes it sometimes like accessible even to those like kind of with limited technical knowledge. They can drag and drop and play around. But it is not ideal for creating the interactive or animated visualizations like Flourish. So this excels in producing detailed static visuals that can be further customized in tools like kind of Adobe Illustrator. This is also a go-to choice for academic and researchers and who need a kind of a highly specific static visuals for publications. for the high impact journals, and for that, researchers and some of my friends also using this, to create impactful visuals on the journals. So the industry using drawgraphs.io is like academia and research and education. The strengths are static charts, detailed data exploration, and parallel coordinate graphs. There is a case study. University professor used drawgraphs.io, to create a detailed visualizations for the research paper on climate change, which significantly enhancing the paper's impact and the clarity. So now we are moving to the major players. So whatever we have seen so far, those are all the free versions, like you can play around and all these things. This from now we are going to discuss about the industry grade or industry top players who's into data visualizations. So Tableau, everybody must have known already, and if you're not knowing this, it's a product which is widely used. One of the most popular and powerful data visualization tools available today. Tableau is known for its kind of a user-friendly the drag and drop interface, which makes it's incredibly easy to create the visualizations. Even for the users without technical expertise, they can use this tool. It integrates with Excel, Microsoft Excel, and the SQL database, and various cloud services, which allows for a wider range of use cases. Like this flexibility, it's a key reason for Tableau is so widely adopted across industries. One standout feature is its ability to create interactive dashboards. For example, like financial analysts often use this Tableau to track investment trends and market changes. These dashboards can combine multiple visualizations like bar charts, pie charts, and even line graphs to provide a comprehensive view of the data. As you can see the example image, the Tableau excels at representing complex data sets in a way that is easy to understand and actionable. It's perfect for business and individuals looking to turn a raw data into meaningful insights that drive decisions making. So let's talk about this company also. The market capitalization of Tableau is like in the recent evaluations, like some of you might know already, might not know already. The Tableau is now owned by Salesforce. It was acquired by Salesforce. Contributes to Salesforce overall market cap across, it's approximately $200 billion. Tableau itself is estimated to account for a significant portion of Salesforce analytics business and revenue, which exceeds $2 billion annually. So the industry is using Tableau. Most of the investment firms, investment firms like fraud detection and financial performance analysis and all these things, and retail. For the sales trends like customer behavior and inventory management, and healthcare, yes, tracks the patient outcomes and resource utilization and public health trends. And technology, yes, monitors the software performances and customer usage patterns. And the education also, they are using Tableau. So there was one case study, like Coca-Cola bottling company. Consolidated, implemented, Tableau to optimize its supply chain and sales process. Using Tableau's interactive dashboards, the Coca-Cola bottling company improved the delivery times and analyze the customer preferences and track the inventory trends in real time. As a result, they reduce the operational cost and increase overall efficiency, ensuring the better customer satisfaction. Next one is Power BI, a product from Microsoft. Is widely recognized for its integration with Microsoft ecosystem and its ability to deliver real-time data insights with features like AI-driven data analytics and seamless compatibility with tools like Excel, Azure. The Power BI is a favorite among businesses looking into the leverage their data efficiently. What does it say? Industries like let's see the market capitalization of this. Market capitalization is part of Microsoft extensive product suite. Like Power BI contributes to Microsoft market cap approximately around $2.3 trillion. And the industries using Power BI, it's retail, healthcare, and manufacturing. So retailers are using for their analyzing the sales trends, customer trends, and operational KPIs, and healthcare using it for tracks patient care metrics, resource allocation, and operational efficiency. And manufacturing monitors the production efficiency and supply chain analytics. The case study, one of the case studies related to Power BI is the Nestle. Nestle adopted Power BI to consolidate their global sales and operations data. With real-time insights and predictive analytics, the company optimized its supply chain and reduced lead times, significantly improving efficiency and customer satisfaction. And the next one is Google Data Studio. Google's Data Studio also we can play around. It's kind of a free for the small things, and it's a paid service. It's a very intuitive tool that connects directly to Google's ecosystem, making it a favorite, for digital marketers and web, because it's connected to Google, and who were doing the web analytics and the digital marketing, they prefer to use the Google Data Studio because it's directly connect to the Google Analytics, ads, and BigQuery, and so the businesses can create shareable interactive dashboards to track campaign performance and customer engagement. And it's a fantastic tool, for the teams looking for a customizable and collaborative visualizations without any additional cost. So it's again the market cap, like it's part of the Google Cloud's portfolio, and Google contributes alpha to Alphabet's market cap is $1.7 trillion. The industries using Google Data Studio is like predominantly digital marketing and e-commerce and small businesses. So the case study connect to Google Data Studio is like Adidas leveraged the Google Data Studio to analyze their e-commerce data, including traffic source, conversion rates, and user behavior. This helped the company fine-tune its digital marketing strategy, leading to a significant increase in online sales. And QlikSense. It's the next tool. It's called QlikSense. QlikSense provides some kind of AI-driven analytics and interactive dashboards tailored for enterprise level solutions. It associates engine, enables a faster data discovery, making it ideal for industries like healthcare and finance. For example, healthcare providers uses QlikSense to analyze patient data, optimize resource allocation, and improve care outcomes. This tool's scalability ensures that even the largest data sets can be explored seamlessly. So Qlik Sense is privately owned, but competes with Power BI. Market estimated, at $35 billion annually. And Qlik Sense, like industries, the use case industries like healthcare, finance, and education, like I said. And the common case study is like the UK National Health Services (NHS) adapted the Qlik Sense to monitor patient admissions and improve operational efficiency by analyzing the admission trends and resource use. NHS reduced the wait times to optimize hospital staff allocation. So if any one of you might, if not knowing about NHS, like NHS is like a kind of a government hospital in UK. So if someone's get fever, they will not get admitted immediately. They will give only the basic fever medicine, and then they will not allow to see the doctors immediately, because there will be a lot of waiting queue, and people will be waiting for a week or two to go and meet the doctor in case if they have severe fever also. So by doing all this, and they can increase the efficiency and analyzing the admission trends, it really helped them to reduce the wait time. And D3.js, it's a JavaScript library tailored for creating dynamic web-based data visualizations. It's again, the open source community product. It's not directly associated with any company or market cap. This one, the industry is using D3.js is like academia creates a complex visualizations for the research data, and finance develops interactive dashboards for stock market and stock market analysis, and the media building engaging visual stories for digital publications. The company used D3.js is like the New York Times. The New York Times uses D3.js to create interactive visualizations for news stories, such as election maps and COVID-19, election maps tracking or COVID-19 tracking dashboards. So it enhanced the reader engagement and information retention. The other one is Looker. Looker is part of the Google Cloud, specialized in modern business intelligence with robust data modeling and visualization capabilities. Like it integrates seamlessly with all the big data platforms like Snowflake and Redshift, making it an excellent choice for enterprise. E-commerce companies are often use the Looker to analyze the customer journeys, optimize inventory, and track sales funnels effectively. So the market capitalization of this company contributes to Google Cloud's overall revenue. Again, like it's $26 billion annually. The industries is using Looker is like e-commerce, finance, and healthcare. The companies using Looker is like one of the famous companies looking to use Looker is like Spotify. Spotify uses the Looker to analyze the user behavior and engagement metrics, helping the company to improve recommendation and algorithms and user experience. The other one is Chart.js. It's a lightweight open source JavaScript library designed for simple yet effective web-based visualizations. It's again open source. It doesn't have any market cap or anything. The industry is using Chart.js is like most of them are startups to visualize KPIs in lightweight dashboards, and education industry and small businesses. So for like a small SaaS startup used Chart.js to integrate real-time performance dashboards into its application, enabling users to track metrics like uptime and user engagement effectively. And Infogram. Infogram is a cloud-based tool. It's designed for creating stunning infographics, reports, and dashboards. It's predefined templates and drag and drop interfaces make it is accessible to users even without any design experience or technical experiences. Most of the marketing teams use this infogram, to create the visually appealing presentations and reports for their stakeholders or managers. Infogram is part of Percy, that contributes to estimated valuation of $100 million. And industries using infograms like marketing, education, and media. The UNICEF used infogram to create engaging reports and visualizations for stakeholders, effectively communicating the impact of their programs across the different regions. And the final one is Denado. Denado is my personal favorite. Like, I have seen this demo and then I have seen the tool, how it's working, but it is expensive, but it is at the same time, it's like they are the leading data visualization platform that provides seamless access to data from multiple sources without needing to move or replicate. The beauty is, like, you may have a SQL server in the AWS, you may have the SQL server in the Azure, one of your product data may be in AWS, your sales data in Azure, or your product data in some Google Cloud, or wherever in-house, on-premises data center, cloud data center, multiple cloud data center. This Denado platform can integrate everything together without copying the data from there or moving all the data to one location. The data can be in the same location wherever they are. This platform integrates with all the providers and create the impactful visualizations, like for the managers or the business owners to take action against it. So, like, the major industries, most of the financial institutions are using Denado. So, like, it's a private company. Again, Denado does not publicly disclose its market cap because it's not listed, and it operates in the growing data visualization market, like kind of valued at $5 billion. Industries, main industries using Denado is like finance, healthcare, and retail. Predominantly finance and healthcare, and there is, I think, there was one university in US also. They are using the Denado platform to, to visualize, getting the visualization of all the students across the country and the other branches, and so they are collecting all the data from across the US and seeing the student engagement and lecturer engagement, and all these infographics they get out of it. And one of the case studies, like Logitech, is using the Denado platform to integrate data from the on-premises and the cloud sources. So this approach, it helped them to analyze the data analytics and significantly reducing the reporting times and enabling real-time insights. I think I have reached the end of the slide, and I think we are on the time. Thank you all for your time and attention today, and I hope you found this session on data visualization tools and best practices, both informative and engaging. And if you have any further questions or would like to connect, feel free to reach out to me on LinkedIn, and you can find my profile at this link. Once again, thank you everyone, and thank you for joining, and thank you Venkatam sir, thank you Mariam ma'am, and I look forward to connecting with you in the future. Have a good evening.
Thank you, sir. Thank you, sir, for your very thoughtful session. on giving a detailed overview about how we need to use the visualization and also the concepts pertaining to visualization. It was really helpful for every one of us who joined over here for today's session. Thank you, sir. Thanks a lot for your time.
Thank you, sir. Thank you again.
Thank you. Dear participants, let's take a 5 minutes break. And yeah, yes, sir. Shama sir, yes, sir. Do you have any questions? Okay, dear participants, let's take a 5 minutes break and then let's have our session 2 started. Okay. Thank you. Hello, sir. Mahendran, sir. Can you hear us, sir?
Hello? Hello.
Hello, sir. Good evening, sir.
Good evening, sir. Am I audible, sir?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Mariam Nancy, ma'am.
Yes, sir. We'll begin.
Yes, yes, sir. Yes, sir. Yes, ma'am. Let's begin.
Okay, sir. A very warm good evening to one and all present here. It gives me immense privilege to introduce Mr. Mahendran E., a scientist E at the Center for Development of Advanced Computing, Chennai. He has been an integral part of the organization since 2010 August. With over 15 years of professional experience, he has established himself as a distinguished researcher and educator. His academic contributions include 10 journal publications and 5 conference papers, reflecting his dedication to advancing knowledge in his field. Mr. Mahendran is actively involved in teaching academic courses and Future Skills Prime cloud training program, showcasing his commitment to knowledge dissemination. His expertise extends to cutting edge projects such as the Meghdut open source cloud project, and he has played a pivotal role in delivering corporate training sessions and workshops for government bodies, SMEs, and educational institutions. His passion for research and development continues to drive innovation and technical excellence in the domain of advanced computing. He will now enlighten us on cloud computing and HPC. With this note, I welcome you, sir. I hand over the session to Mr. Mahendran. Thank you.
Thank you, ma'am. Good evening, all. Am I audible and I have shared my screen. Whether
So, sir, your voice is very bit low now.
is it okay, sir, now?
Yes, sir.
Okay. My screen is visible, sir.
Yes, sir.
Thank you for the warm welcome, ma'am. Okay. Let Today's topic is about cloud computing and HPC in industry. This is the topic which is we are going to learn about it. Before starting the session, first thing is for the past 3 days you are on HPC. You are in the workshop of high performance computing, and you also know about something called supercomputers. Before starting the presentation, I just tell what is our organization is. CDAC, Center for Development of Advanced Computing. We are a central government entity under Ministry of IT, Electronics and Information Technology. CDAC is also called as the supercomputing people. We are also called as supercomputing peoples. We are having all the supercomputers. Our latest release of the supercomputer is Airavat. This is the supercomputer in 2020-23. It was ranked 75th in the world. It was ranked 75th in the world. Other than that, we have Param Utkarsh, Param 1000, 10,000. We have all supercomputers. And we are also in HPC. We are also in high performance computing also. Now, this is the information about my organization. Now, we are just going to have a brief introduction about cloud computing and HPC. You are already you're there. you're being there for 3 days in the HPC. First, cloud computing. Cloud computing is very, very simple. In your day-to-day life, you are using cloud. In your day-to-day life, you are using the cloud computing. Example, you are using the mail services provided by Google. It is one of the example of software as a service. Then we have another thing called Google Drive is there. On that you have docs, spreadsheets and PowerPoint, and you have more on that. It is also called as platform as a service. It is, we are not going to install anything. Already the built-in platform is available there. We are going to use it. That is platform. Then infrastructure as a service, IaaS. That is simple, your mobile phone, your Android mobile phone. You are telling I need this much of RAM, this much CPU, and I need the storage with the operating system. This is purely infrastructure as a service. You are getting the mobile phone and you are installing what are the apps which you are needed. That is infrastructure as a service. These are the main three basics services of cloud. Other than this, now everything as a service. HPC is also as a service in cloud right now. Cloud is separate, HPC is separate. Now it has been merged. In cloud computing, HPC is as a service. And you know HPC, it is a high computing system designed to solve complex problems in complex and computational problems. We will have some case studies in the upcoming slides. We are having some case studies. In cloud itself, this is a small definition of cloud. On-demand self-service, which we can access over the internet. If we have internet, we can access that service, we can work on that service. That is the definition of, this is the basic definition of cloud. And there are some main characteristics. Pay as per you go, pay per model. We are not going to own the server. We are not going to buy the server. That is something called as CapEx and OpEx. Capital expenditure and operational expenditure. Capital expenditure in a sense, we have to buy it and we will work on it. That is the CapEx model. OpEx in a sense, it's only operation. Example is, we are booking call taxi. We are not going to buy a car. We are just going to book a taxi in Ola or Uber or Rapido, anything in an app. And how long we are traveling, we are going to pay for it. How long and how much distance we are traveling, for that only we are going to pay for it. That is pay per go model. That is called as OpEx, operational. And other than that, it has a number of features: scalability, cost effectiveness, flexibility, and elasticity. That is one of the main feature of cloud. That is one of the main feature of cloud, elasticity. Then service model, we already done with it. And we have the deployment model, something called as public, private, and hybrid. That is simple. Public means anyone can access, any general public can access the cloud and they can work on it. That is a public model. Private in a sense, within the organization, they will use it. Hybrid, they will tell, in general, they will tell a mix and match of public and private. But hybrid is with the example, I'm just telling, hybrid is something different. For example, Amazon, it is called as AWS, not the e-com side. It is AWS, Amazon Web Service. Amazon is owning data center across the world. More than 19 regions, Amazon is running its cloud. And he has a private cloud as well as a public cloud. Public cloud for general users and for corporate organizations, for everyone. And he has a private cloud for doing his R&D, research, development, testing phases, everything on it. For example, Amazon will use this public cloud as a hybrid model for testing some softwares. How it will be if I put it in the real time entity, a real world scenario, how the software will be used. How the software will be used. You may know about it. Everyone will have Amazon in your mobile app. Amazon has something called as Amazon Lens. It means if I take a photo, using Amazon app itself, Amazon Lens app itself, it will check. For example, it will take your dress, your shoes, your pants, and if you're wearing glasses and watches, it will take everything and it will search in the Amazon site. It, it will take everything. It will take, hello? Hello. Yeah, thank you. It will search the things in the Amazon site and it will just display it. And now the next level is this is with a photograph. Now Amazon is coming with a video. If you're seeing a video in Amazon Prime, for example, if you're just stopping it and if you give a search button, what are the things which are in the video from the background, front, everything, it will take it and it will search. For example, if you freeze it in a cupboards or in a laptops or in anything with the background pictures, everything from the video itself, now it is capturing and it is searching in the background. Why I am telling this is Amazon has both its cloud as well as HPC parts. The video it is taking, it is full and full using the high performance computing for doing the search within a fraction of seconds. You should get all the components which you see in the background of a video. It will be displayed. These are the components which is available in Amazon. For this only, I'm just telling this use case or example. And now we just have another brief in cloud. In cloud, we have tell these are the service model, infrastructure, platform, and software. And the deployment models are public, private, hybrid. And there is another thing called community cloud. There are initially 4 deployment models are there. Community cloud is for a certain community of peoples only working on that cloud. For example, if they are building a financial cloud, for, you may know, we have Reserve Bank of India. On that, something called as IFTAS. IFTAS. It is a Reserve Bank Governing Council. For that, it is specialized for information technology. They will build a separate cloud only for the banking sectors alone, which is some public facing application also will be there, and the general usage within the banks. They have to update something for the Reserve Bank. This application will be common for them. This is called as community cloud. And we are telling cloud, but the underlying architecture of cloud is virtualization model. Underlying cloud architecture is virtualization. It means virtualization, you know, physically it is not there, but virtually the machine is running somewhere. The machine is running somewhere. It is simple. A single physical machine appears as multiple logical machine. A single physical machine will appear as multiple logical machines. That is called as virtualization. On that, we have different kinds of virtualization also. There are type 1, type 2 hypervisors are there, and we have full virtualization, para virtualization. These are the virtualization models which are available. And there are mainly major players also there. Red Hat is there in virtualization itself. Microsoft Hyper-V is one of the main virtualization. And we have VMware, ESXi, VMware Workstation is also there. Workstation is for general usage. For a normal users, they can just install in a desktop or in a laptop and they can use it. And ESXi, it is something we have to install on the server and we can virtualize more. These are the virtualization, some virtualization softwares. If you want to test with it, you can go for Oracle VirtualBox. That is a free software which can be installed in either Windows or in Linux. You can install on any operating system. And these are the roles of cloud computing in the industry. The main thing is data storage and backup. Everyone tells my data should not be get tampered or it should be safe. I should have a backup. Now, for example, in olden days, now we are using with Android phones. Before Android phones, we are using a normal Nokia 3310 like that phones we are using. And if you save the number, it will be saved on the mobile or on the SIM. There is only two options are there. The mobile number will be saved on the mobile itself, or it will be stored on the SIM. The SIM can store only 10 to 15 contacts, a max. But now you can see, if you take your mobile, minimum 200, 300 contacts are storing. It is storing in the Gmail. Gmail is obviously running a background in the cloud. Automatically it goes to the cloud. The data storage, every contacts of your mobile phone are storing there, and the backup is there. If you lost your mobile also, no issues. If you buy a new mobile and log in with your username credential of the Gmail, and if you put a data sync, all the contacts will be synced to your mobile. That is the data storage and backup. And the application development and deployment, this is also called as CI/CD or DevOps, development and operations. This is being widely used in cloud computing platform. In before cloud was there, what we have to do? We have to take a server, we have to install the operating system, we have to put the softwares which we want to develop. For example, a Java with NetBeans or Eclipse editor or Wizard, or you have to go with the database, you have to install it, configure it properly, and you will work on it. Now it has been pre-built. If you tell I need a system with 32 cores, 64 GB of RAM, 200 GB of hard disk, or 1 TB of hard disk, it will be available ready. And what are the softwares you want? You're just clicking, it will install, configure everything and give it to you. What you have to do? You have to just work on it. If you crash also, on the next 5 minutes, you can create a new mission and you can put your codes there and you can work on it. That is application development and deployment, development operations. After testing your tools, your codes, you can put it in the staging environment. It won't go to the live environment. In industry, what they do in a sense, they have a development environment separate, they will have a testing environment, and they will put it in a staging environment. Staging is before it go live to the users or to the client, they will put it to another staging environment where they test it rigorously. They will put continuously 100 users are accessing the page. How is the performance? 100 users in testing, they will simulate the thing. They will put 100 users, 1000 users, 2000 users, like that. They will simulate it. But in staging, they will put, and they will give to the organization to just log in and check what is the thing which is happening, how the application responds. They will tell just to check outside network, within the network, outside the network of the organization, like that they will put in the staging. After it passes the staging, it goes to the production or live environment, where that the application will be directly used by the clients or by the users. It will be directly used by the clients or by the users. Sorry. And the another model is AI and ML model trainings. Now AI has become a part of the entire computer science stream. It will come everything with AI. Example, starting from ChatGPT, Gemini, everything is with AI. We are not going to do anything. We are just giving the things. It will just execute and get me the output. And in the last, I will show a demo of Amazon AWS. On that, you can see what are the AI models which are available in Amazon. You cannot able to just visualize it. That many services which are Amazon running. That many services which are Amazon running. And we have the big data analytics also. There is something called EMR, Elastic Map Reduce. It is like a cluster. Cluster in the sense more than one nodes, not a single node, more than one nodes. We can tell what these are the software to be there in my cluster. A cluster will be created and it will given to you. And the benefits of using cloud is already I told pay per go model. How long we are going to use it, we are going to pay for it, not more than that. And scalability and flexibility, rapid deployment and collaboration and accessibility. Scalable and flexible in a sense, my cloud can be scalable. For example, in this, I have already told something called as elasticity. It means I have a system in cloud which is having a 32 GB of RAM with 16 or 8 processors and 300 GB of hard disk. When my system, my CPU or my RAM reaching a threshold of 70 or 75, elasticity feature will be automatically enabled. If my, what will happen in essence, my CPU and my RAM or any one of the thing also, if it reaches 70%, if for example my RAM reaches 70%, automatically my RAM will be increased from 32 GB to 48 or 64. It will be dynamically increased without any downtime. Without any downtime. This is called as vertical scaling. This is called as vertical scaling. Horizontal scaling in a sense, I told I have 32 GB of RAM, 16 CPUs and 300 GB. The same set of another new VM will be created and the traffic will be rerouted to the new VM. The traffic will be rerouted to the new VM. It will be automatically, it will configure, but we have to enable the future. We have to enable the feature so that it will be automatically get created. It is something called as, if I, for example, if I have two machines, I will have only one URL. How I can be able to access it? There is something will come on the other side. It is called LLB, load balancer. The DNS will be mapped to a virtual IP. That virtual IP mapped to the load balancer, and which for two servers or three servers, which is having less requests. For that, the new request will be redirected. That is called as scalability and flexibility. Rapid deployment in a sense, we no need to wait for the machines. If I just click, I want this machine, this configuration, either Windows, Linux. Now Mac is also, we can able to create a VM. Initially Mac was only we can able to install on a particular hardware. Now it is not like that. A VM itself can be with Mac operating system. A VM itself can be with Mac operating system. Any Linux, CentOS, Fedora, anything. For example, if you want to install it, first you have to download the ISO. The ISO itself may have 2 GB or 3 GB. The downloading itself will take time. It will take 1 hour or 1.5 hours, for example. Now it is 45 minutes also. After that, you have to make it as a bootable drive and you will install on your system. Total, it will take 2 hours for installing operating system. But if we just go to the cloud, I just click it, 5 minutes, I will get the machine. I will start deploying my application or develop my application. That is the key benefit of cloud. Most of the industry during the COVID times, most of the industry has migrated to cloud. They have the servers, everything there, and they will just create a virtual. There is something called as VDI, virtual desktop infrastructure. I have created a VM, but it is running somewhere. How will I get the full? In your normal desktop or laptops, you will have a UI, user interface. You will just log in with your username, passwords, or you will have your key, a pin. With that, you will just log in. The same thing. There something called as VDI, virtual desktop infrastructure. It will be running somewhere. You will have a file, else you will have a login. A URL will be given to you, a login will be given to you. If you just log in, you have your mission on the screen itself. That is called as virtual desktop infrastructure. During the COVID times only, these are the features which has been highly utilized. Then there are mainly two case studies, Netflix and healthcare using AWS genomics. Netflix, they are using their video to stream on the cloud only. We are seeing the streaming videos. We are just seeing the streaming videos. Here, there are two things are there. For the transaction based, we are using the TCP protocols. For example, if you are paying your online payments, for these kind of stuffs, we are using the TCP protocol. For videos, YouTube videos, Netflix, online videos, every videos, they are using UDP protocols, user datagram protocol. In transaction, if I lost 1 or 2 packets, my transaction will be declined. My transaction will be get cancelled. But in the streaming videos, it will use UDP. If I lost packets also, no need to worry. My movie will continue as such. When whatever this movie I am seeing in a streaming, it will be continued as such. The use case is Netflix, they are full and full using cloud for streaming their full videos. The entire Netflix servers which are running with cloud. And healthcare, there is something called genomics. Genomics is just a tool in Amazon for just predicting the, for example, the DNA structure or molecule structure. If you just give the inputs, it will just predict it. And these are the main 3 things in HPC. There are 3 kinds of computation will be there. One with CPU, another with RAM, another with GPU. The main constraint, why I'm putting this is, the main constraint of a HPC system is it is very heavy cost, very cost. It is highly. We cannot run a normal system for the application. A simple example I can tell, this is a use case which we have tested lively. We are just conducting some exams for some defense. For Indian Air Force, Indian Navy, Indian Coast Guard, we are conducting the exams. For that, the question paper generations will be in a system. The question paper generation essence, there will be a software, the questions will be feeded with a priority of high, medium, and intermediate. Now we will generate 100 questions from physics with a statics of high with 20, medium with 20, intermediate with 10. Totally, I am generating with 50 or 100 questions in any combinations. We generated 100 questions, which is in a cloud environment with a tool called Llama. It takes nearly 50 minutes to 60 minutes for generating 100 questions. 50 minutes to 60 minutes for generating 100 questions. This is with the normal cloud, with a normal system, CPU system. Now, what we did in essence, we are having the HPC system. So we plan to put the same software there and we have just executed the same conditions, generate 100 questions in the same physics, and we have just run it. We have got the output within 15 minutes in a HPC system. We have got the output in a 15 minutes. This is the difference. For what is the application we are going to use, for that we have to go with the HPC, else we can go with the normal system also. And another one thing is also there. For exams, we have to generate hall tickets. For example, 1.5 lakhs hall tickets has to be generated. If we run the codes in the cloud system, it is in the cloud system. If we run it, it runs for 16 hours for generating 1.5 lakhs, generating hall ticket for 1.5 lakhs candidates. It takes nearly 16 hours. After that, we have changed the code. We have checked it why it is taking so long. It is just, for example, I have given 32 CPUs for the particular VM for generating whole ticket, but it is utilizing only one CPU. The entire code is running with the one CPU, so that it takes 16 hours. After we are changing the entire code structure, changing the entire code structure. It ran in 3 hours for generating 1.5. You can check 3 hours is here, 16 hours is there. This is the difference. Our application, what is the code which are going to write, that should also support the, we have to write the code in a manner so that it will also be supported with the high computing infrastructure or a cloud infrastructure. And these are the main characteristics of HPC. Extreme computation power. You may know it will be in flops, floating points, and specialized hardware with GPUs and accelerators. Now we are telling with HPC with GPU cards also. Mostly the GPU cards will come with NVIDIA. The GPU cards will come with NVIDIA, and there is something also called as InfiniBand. InfiniBand is mainly for network communications. InfiniBand is mainly for network communication. It is mainly used for high performance computing with very high throughput and very low latency. With high throughput and low latency. It will minimize the latency and enables fast data access and transmission across the cluster or nodes. We will deploy, for example, we are running a data center. On that data center, we will have a rack. On that rack itself, on the top, we will have the switch. We don't have the switch on the next rack or on the third rack or fourth rack. We will have the switch on that rack itself for data access and transmission. If I put the rack in the another 2 or 3 racks after that, the data transmission, my latency will little bit increase. And the thing is, we are using the fiber optic cables, FC cables for fast data transmission. It means in a normal Cat6 cable, a normal network cable, it will go for 1 Gbps. But if I am using a fiber, it will go with 8 Gbps. They will tell 10, but actual, the fact is it will go with 8 Gbps per second. I'm telling with per second. If I want to transfer a file from one server to another server, it will just transfer. If it is 50 GB or 100 GB in any GB of size, within 10 minutes, the max of 10 minutes, it will transfer. And we use something called L3 switches, layer 3 switches, which is each and every port is configurable. How we configure in a sense, you may know in normal desktops and laptops, we have only one network interfaces. But if you go for server, we have 4 or 8. A minimum with 2, a maximum with 8 network ports will be available. On that, we will configure the ports with, if it has 4 ports, we will configure the first 2 port for management, for data transmission, within clusters. The other next 2 ports for outside transmission. Within the cluster, I will configure with 2 ports so that if my one port goes also, another port will be there. It is called as fault tolerance. Then the other 2 ports, what I do in a sense, to configure outside the cluster network, for the user accessing the application or taking the backups or transferring some files within the cluster. For that, I will use the next 2 interface so that my application performance won't get affected. And one of the best example of HPC is, you may know SAC Ahmedabad. It is a ISRO space satellite station. The satellite images are processed there in the SAC Ahmedabad, and they will given. The satellite images will be captured and it will be processed. The grains, the noise will be, they use some filter algorithm, low pass filter algorithms, and the noise of the images will be removed fully. Then you will get a clear image. Where is the full sky is there, where the rain is there. If you see the weather reports, it shows something, a cyclone is formed here. But you see the other thing will be very clear. The cyclone will be specifically in some areas in the coastal, like that. These kind of steps is fully processed using the HPC. Before HPC, the old technology. Before HPC, there is something called cloud. Before that, we have something called grid computing. Based on grid only, the cloud and HPC has come in picture. Why grid has failed is grid doesn't have any application to stand. That's why grid has been failed. The grid computing technology itself has failed. HPC is the enhancement of grid only. The same thing in HPC, you have something called as schedulers. You have something called as schedulers, workloads, everything are there in the grid computing also. The clusters, everything, what are the things you are studying in HPC? The same set is available in grid also. And this is for regarding high-speed interconnect only, we are using InfiniBand. And the applications, scientific simulators, financial modeling, weather forecasting. Now only I have told the weather forecasting about the Sag Mahmoudabad and scientific simulation. Scientific simulation in a sense, have you heard about something called CERN lab? CERN lab. It is, which is also called as God particles lab. CERN lab, which is located in, it's a European organization for nuclear research. This is the world's largest and most heavily used the high performance computing systems. It is something called LHC, Large Hadron Collider. It's the world's largest and highest energy particle accelerator. Initially, I think few years back, the CERN lab has introduced the God particles. They have just used the God particles. They use, before HPC, they have used the grid computing platform for doing that. Now they are using the HPC systems for the using the high energy particles accelerator. This is the best use case for scientific simulations. And the role of HPC in industry, scientific simulators, engineering. In engineering, there is a, in the upcoming slide, there is one slide is there. Ford is using, the Ford car company is using HPC model for crash test. How if it crashes directly in a wall or in a two cars are hitting directly, and if it crashes in a 30-degree angle, what will happen? The full crash test is being simulated in the HPC environment, the whole crash test. And in financial modeling and risk, you may know the Sensex, NSE, Nifty, everything will be there. You can see the closing time is 3 o'clock or 4 o'clock. On that time, heavy transactions will be there. Lot of transactions. The stocks will be exchanged among users or with the brokers. Everything will be there. All the transactions are running in the HPC platform, so that it will be very fast. You cannot see any difference if you use the app or if you use the laptop directly. The same application in the app is also same, and in your laptop is also same, in your desktop is also, so that it will be very fast of accessing it. And used for large scale data processing. Large scale data processing, in a sense, there is something called as deduplication. Deduplication in a sense of Aadhaar. We have just conducted a proof of concept for removing the duplicate entry of a Aadhaar for a particular district in Tamil Nadu. We have just run it. For that data pre-processing, what we have used in a sense, we have used the cloud computing system with the big data applications, big data software for running this deduplication. This is called as data processing. And the main benefits are high computation speed. We have the flops, inflops, petaflops, teraflops like that. And it can handle complex workloads. And the performance will be parallel. And these are the main two use cases, NASA simulation and automotive. The automotive crash test is by the Ford car company, and NASA simulation. Simulation in a sense, in India, we have something called as DRDL, Defense Research Development Lab. That lab is for just there is one thing called wind tunnel test. They have something called wind tunnel test. On the tunnel, they will just float a small prototype on it, and they will blow the air. They will blow the air. It like blowing in a sense, not in 10, 20. It will be 100, 150, 200. If the air just blow in front, what are the parameters they will take? For a missile, there are 16 parameters are there. Starting from alpha, delta is there, pitching moment, yawing moment, like that. We have 16 parameters for that particular missile, the prototype. If it blows directly in front, what is the thing? And if it blows from the back, from the side with a 30-degree, 40-degree, and 90-degree, what will be the result? The test results will be there. From there, they will take it, all the test results. After that, only they will build the actual type. From that result only they will analyze and they will build the actual. This has been full and full carried by the HPC systems. The wind tunnel test for the missile simulator. It is a simulation model. The entire thing is carried out by the HPC clusters. This is the example of the NASA simulation. And challenges in cloud and HPC adoption. The main thing is, if you are telling over the internet, we can access the resource. The first thing will come is security, data privacy. First thing will come. Now we are using mobile phones, two-level authentication for logging into your Gmail itself. You have to put the username password and you have to put the OTP. Then only it will get logged in. And you will tell the application which I am accessing is slow. For example, you think of it, there are a number of users who are using Gmail accounts, but no one feels Gmail is slow. The latency is the network. If the network slow only, you will face the issue of the mail loading will be slow. But if the network is good, no one will feel that application Gmail is slow. That much fast they are able to give, not for a single user, not for 1,000 users, not for a lakh. More than in India itself, they are just providing 100 crore users. We will just create multiple accounts. Gmail is giving free, but why is giving free? For every person, he is giving 15 GB of data. 15 GB of data for each and every account. But for the Gmail is also giving for corporate accounts also. For that, he is giving 50 GB or 100 GB, depending upon the policy which the corporate is putting a SLA along with the Google. But no one is feeling the mail is slow. That much the application is built and it is running in a cloud environment also. For certain users, it will be running in a cloud. But for the corporate user, it will be run as such separate, not on the same system. It will be separate. And vendor lock-in. For example, vendor lock-in in a sense, if I created an application and deployed in Amazon and I have given to some public users, it will be locked in the Amazon itself. Else, if I create a VM in Microsoft Azure and it will be locked in Azure, not like that. It can be now there is something called as interoperability. If you run a mission in Amazon Cloud, you can take the same mission and you put it in Google or VMware or Red Hat, anything, it will run. Anything, it will run. And the main challenge of HPC adoption is cost. The HPC system itself is very high. The cost of the systems are very high. For example, now we are telling with HPC. There is something also called as HCI, hyperconverged infrastructure. HCI. It is like a box. Box in a sense, I'm buying a server with some configuration installed with my pre-built application. I just take outside and put it in my rack server, rack system, give network and boot it, and will start working on it. That is HCI systems. HPC systems will come, it will also come as a box with a normal processor or a GPU processor. It will come with a normal or a GPU processor for running my applications on that. That is the difference, but the cost is high. And energy consumption. Energy consumption is with respect to power. In cloud, in one server, I can launch n number of machines, but in HPC, the single server will be dedicated to a particular workload or a particular job. We will call it as a job or a workload to till until it finishes. After that only the server get released, another job can be executed on the server. The HPC systems, most of the systems are parallel. The application, it will generate the, for example, image processing I have told, it will just what does in essence actually, it will take the image and cut it into chunks, blocks. Every blocks will run in separate nodes and the output will be aggregated finally. It is a independent job. Something also dependent jobs also will be available there. Dependent in a sense, if I cut a chunk, if I remove the things, the noise and grains, and but it has to be checked. For example, a cyclone is there. If I just remove it, the cyclone will be also will be get removed from the satellite image. That things is dependent on some images, some chunks it is. And the convergence of cloud computing and HPC. I have already told HPC is also coming as a service. HPC AAS is a service. High performance computing as a service and integration with AI and ML with HPC on cloud. Why AI and ML is coming in a sense? HPC server will run the application, but I want the application to be smart enough for running it, making it, getting the output very fast. For that only the AI and ML model are coming in picture. And in cloud, there is another thing. Now we are telling us virtualization. Now after virtualization, container is there. For managing multiple container, Kubernetes orchestration levels are there. In the HPC server, now they are putting. Before this, like I told, if I run a workload, it will run on a particular system and get the output. But now if you're using the container or Kubernetes kind of stuff, the container will run independently. It will run in the HP system. I can run multiple containers the same system and reduce the running time of an application. This is the trend of it. And the advantage is if HPC comes into cloud, cost will be reduced mainly. And then my resources will be flexible and scaling. And democratization of HPC for smaller enterprise also. For example, someone want to test a small set of codes, they cannot be able to buy it. I just can create a container or a virtual machine on the HPC server and they can run and they can take the output. That is the main advantages of convergence. And the challenges, the same thing, the data transfer will come. If you use InfiniBand only, the data transfer rate will be high throughput and low latency. Always, if you tell security is a concern, but actually if there are multiple machines are running on the same server, the server itself don't know the data of both the machines or n number of machines running on it. Everything is secured by, there is the data decryption algorithm is also there. By using that, every system will be secured. And licensing and the software compatibility. Now we have for HPC, there are n number of softwares are there. Free and open source software is also there, and commercial software is also there. From Dell, there is a software called Apex. Dell Apex, it is for HPC, high performance computing. This is our licensing model. How they will give the license in essence? They will give the license in means of cores, processor cores. That is the model. VMware is also following the model of processor and number of processor, number of core. This will be the main challenge. If I just get a particular product with the number of cores and CPU, I will be locked within the vendor itself. I cannot use more than that. If I buy a new HPC system, I'm not able to install the software and run the codes. And these are the difference between a cloud and a HPC. The architecture is HP cloud is distributed and virtualized. The whole cloud is distributed across regions and virtualized. And HPC is centralized and parallel running jobs. It is using parallel computing. It runs the jobs in a parallel manner and aggregated. And the performances, this is mainly used for general purpose. Your normal applications. Your normal applications will be running for that. But HPC is for specialized and high throughput applications. Specialized and high throughput. And this on-demand scaling, I already told, horizontal scaling and vertical scaling. But in HPC, it is very limited by the hardware constraint. It is limited by the hardware constraints because of the GPU cards. The cost is pay as per go, but if you go for directly buying HPC system, the upfront cost, in a sense, my infrastructure cost will be very high. And the use cases are my data storage, web apps, machine learning workloads. Here, my simulations, CFD, and in scientific research organizations, these are the use cases of HPC. Before this, we'll just have a demo of AWS. After that, we'll just, there is only 4 to 5 slides. We will just continue on it. My screen is visible. I have just shared a new screen, which is with AWS. Okay, this is AWS, which is Amazon Web Service. This is my home page. After logging with my username password, I'll be landed up here. And you can see here, these are the data center regions of Amazon. In India, it is in Mumbai. In India, it is in Mumbai. If my mission is not there, if I'm going to create a big mission or a specific service, if it is not available in India, it will go to the next nearest region. Okay. Now I'm just going to create an instance. It means a virtual machine. It is something called as EC2, Elastic Compute Cloud. Elastic Compute Cloud. Now you can see this is my dashboard. I'm going to create an instance. There are 0 running instance. You can see running instance is 0. Key pairs is 5 like that. Now I am clicking running instance. No instance which is running there. I'm going to create an instance now. Launch instance. Why it is instant presence? Within a fraction of minutes, within a maximum 5 minutes, it will be created. Now, the first thing is I'm going to give a name for my mission. I'm giving just giving my name to the mission. Now, here you can see I have told Mac operating system can be also created as a virtual machine. Amazon has its own Linux. Mac is also there. Ubuntu is also there. Windows is also there. Now I'm clicking with Windows. You can see Windows Server with 2025. With 2025 in essence, the version of the Windows operating system. If I click on Ubuntu, it gives Ubuntu 24 LTS. LTS stands for long time supports. Whenever we are selecting an operating system or any software, we have to select with the stable version only. We have to select with the stable version. Look, with this is with Ubuntu. If I just click on the drop down, I have 24.04, 22.0 is also there. Now just selecting with 24 itself. Now it is asking for the architecture, whether it is a 64-bit x86 or a ARM. Initially, the operating systems will come with specific architecture, 32-bit, 64-bit. 32 in a sense, it will be only will be working on the desktops and laptops. 64 only will be working on the servers. Now it is not like that. Everything is coming with 64. Now I have just selected with 64-bit. Now these are the type, flavor. They will call it as flavor or type. It means how much CPU, RAM and hard disk you want. This is the type of it. You can see 1 CPU, 1 GB of RAM. This is the minimal flavor. If I click on it and just scroll, it gives 1 CPU, 2 GB RAM. If I just scroll down, you can see here something called 64 CPU, 128 GB RAM. This is for a single virtual machine. 64 CPUs, 128 GB RAM. Else, next is 32 CPU, 64 GB of RAM. In any combination, we can just create the machines. Now I have selected with T2 micro. Then key pair. Key pair is something public key and private key. With this key only, we are able to log in to the particular machine which we launch. If we lost the key, we cannot be able to log into the particular machine. Amazon is giving an uptime of data, not uptime, data backup of 99.999% uptime. If the entire system crashes also, Amazon will be able to get the full data backup for you. Now, I'm just going to create a key pair. Look, here itself it shows. You're just in your normal, we study RSA, DSA keys. The same keys only used for generating the key pair. The same algorithm. I'm using RSA, a PIM key, a private key format will be created. Just clicking create key. Now the key is downloaded. Now the network settings. What is the VPC, Virtual Private Cloud Network? That is called as Virtual Private Cloud Network. Now I'm just giving with the default. I'm not going to specify anything. This is something main. If I for a Linux system, it will ask for SSH. If it is a Windows, it won't ask. Look, now I have selected with the Windows. For Windows, it is not asking. For Windows, it changed to RDP. RDP is Remote Desktop Protocol for taking the entire machines. And this is the size of it. Now I am clicking launch. Just I have given a name, selected an operating system, selected a system size, then I have created a key. Only 4 steps. Just click launch. Successfully initiated the launch of instance. Within 3 minutes, the entire mission will be ready. We can just access the mission. You can just access the mission. Now it will show the status here. Look, it shows T3 micro running. It comes to running, initializing. Now the mission is getting created on the background. This is how the cloud. This is one as a user, as an industry part, I will tell. And in Tamil Nadu, there is a scheme called Nan Mudalvan. This is a upskilling and reskilling program of Tamil Nadu state government. They are not telling training now. They are just telling upskilling and reskilling. What it does in essence, they are just providing training for the college students of engineering college students. Engineering college students of any branch. They are giving training. For mechanical, they are giving in CAD. For computers, they are providing training in Python, everything. The entire infrastructure is just with 8 virtual machines, which is running in a state government data center called LCOT, which is the IT wing of Tamil Nadu which is just running with 8 systems, 8 virtual machines, 8 virtual machines, which is running there with everything with more than 32 or 64 GB of RAM and with a hard disk of 2 terabyte. How I am telling is we are just operating the cloud in LCOD. This application is running in our cloud only. We are operating the cloud infrastructure in LCOD for more than a decade. From 2012 onwards, we are running the cloud in LCOD in Tamil Nadu State Data Center. We are running with more than 200 plus application with 600 plus virtual machines in just 20 physical machines. In 20 physical machines, we are running 600 virtual machines and 20 government applications, starting from non-model when, for example, on the COVID time, there is something called Stop COVID, COVID-19, these applications, the state government applications, everything which is running on the 20 server itself. This is the industry. In the industry, how they are using the cloud in industry standard, how they are using the cloud. Banking sectors, everyone is using clouds. Look, now we are just going to access the machine by just clicking the checkbox here and connect. Since it is a Windows, I need to download a RDP file. This is remote desktop client file. Just downloading it in my desktop, and I'm going to log. For Windows, there is the key. If I give the key only, it will generate password. If I lost the key, I am not able to log in. I am going to upload the key which I have created. The key is Mahendran. So this is my password. Think how big Windows is giving. Now I'm just going to log in to my mission. Sorry, that screen is not shared. Now I'm going to connect it. I'm just pasting the password and clicking OK. Look, now my Windows machine is there. This is also called as RDP or VDI, Virtual Desktop Infrastructure. Virtual Desktop Infrastructure. Now my Windows machine is getting booted. The same way we can boot the Linux. In Linux, you can able to access through SSH. SSH is a secure shell, which will be in command prompt, or we can also have the UI itself. Look, the machine is fully created. This is the VM which we are in the black screen. Now you can see this is a Windows server. My base machine is also Windows, but this machine is the server edition. My laptop, which is a Windows 11 version. Just going to check the version of the operating system. Look. So this is with Intel Xeon. I have just created with only 1 GB, but if you check the Windows 2025 server or any server, they will give a minimum requirement of 4 GB or more than 8 GB of RAM with 30 or 50 GB of hard disk. I have just created with 1 GB itself, and it is a 64-bit processor. Look, the version is Windows Server 2025 Data Center version. This is the best example for cloud. Now we are just going to see about HPC. Again, I will just share. Now my mission is I have created and I'm going to terminate it. There's, it is the same like if I don't want, I can just click shut down, it will be shut down. If I start, it will start the mission again. How long I am using, they will bill monthly basis. They will bill on monthly. If you not charge, they will put the bill like anything else. For me, what happened in a sense, my friend has created a VM in Amazon and he forgot to terminate it. It ran for a month and they have billed me with 18,000. These kind of stuff will be also come. Now I am just giving terminate. If I give terminate, the entire mission will be deleted. The entire mission will be deleted. Now, in this is regarding cloud. Now we are coming to HPC. HPC is something called, we have for HPC, there is a separate service called parallel computing service, which is running. And if you know the Slurm, everything, the schedulers, everything, we can just go and create the environment and we can run a workload on it. Else, EMR is also a HPC model, elastic map reduce. In this, you see how they are making the cluster. Within the fraction of second, they are just creating the clusters with a number of nodes, everything they will ask. They will just prompt what is the name of the cluster. And here you can see what is the build you want. EMR release 7.5, 7.4. If I select it, automatically the versions will be changed here. Now, if you just scroll, look, these are the services. If you just select what are the service to be installed in your cluster, here Livy, Hue, Hadoop, Juniper Enterprise, Hive, Spark. These are the services will be by default. If you want anything specific, I want TensorFlow. Just click on TensorFlow. This is the version to be installed. And what is the size of the machine you want? Here it automatically goes to 4 core, 16 GB of RAM. It gives 4 core and 16 GB of RAM. And you can see the cost also. This is for the primary. It means it will run in a master node or a head node, compute node, they will tell in cluster conventions. This is primary and this is the node configurations. This is 4 CPU, 16 GB of RAM. And task 1, what is the size? And these are the hard disk. Here you can see something called as throughput. This is with respect to network and you can see IOPS, input and input output operation per second. And the scaling, cluster scaling and provisioning. What set the cluster size manually. Use EMR, EMR managed cluster service. If I put cluster service, I can tell number of instance 1. How many number of instance I want in core, I want in task. Like that I can give specifically, and this is with network. The same VPC, virtual private cloud. And what is the subnet? Subnet instance, there is something called as floating IP is there. Private IP, floating IP. Private IP in a sense, for communicating these two machines, they will have a separate IP address. For accessing for this machine, I will have a separate IP. That is called as floating. And within access of these two clusters, these two machines within the cluster, it is called as private network. And what are the properties of this? This is called as EC2 security groups. Security groups in a sense, firewalls. From which mission the request has to come, what are the mission can access the nodes. In, with the example, application database service will be there. Application database will not be installed on the same machine in any live environment. Application will be installed separately, DB will be installed separately. From application mission, they will write the firewalls. This is the DB mission. This port alone you can able to access from application, and from DB all the every ports will be closed. DB, why DB has to access other servers? Why my database has to access by other servers? Only from application, the particular IP and the particular port will be written in the firewall so that they will be able to access it. Now, these are the properties. If I just click create cluster, within the same 3 to 4 minutes, this entire infrastructure will be there. This is for HPC. This is for the HPC cloud environment. Now we just go and finish the last 2 to 3 slides. And these are the cloud and HPC integration. We just integrate HPC in cloud. What are the main benefits we will get it? Resource allocation. If HPC is cloud burst, they will call cloud burst in a sense. If I am submitting n number of jobs, my HPC cluster is not able to perform it because unavailable of resource. So that I'll use the cloud environment for finishing my workloads. For example, for that only I have told AWS has parallel cluster and Azure has a HPC system called Azure Batch. And if they come with the hybrid model, they will have on-premise HPC and cloud bursting for cost effectiveness. They will have the HPC system in a private organization and they will have the cloud in a public environment. If there is no availability of the HPC, it will go to the cloud and access the HPC service, finish it and come back. This is for pay-per-go model. How long I am going to use that specific HPC server, which is outside my organization. I will pay for it. For that, there is something called we have to use the VPNs, dedicated tunnel networks, which interconnects. For that, we have to use InfiniBands for data transfers. We have a cluster in HPC, 5 systems will be running. I need another 5 more system in the cloud so that my jobs, my workload will be get finished fast. For that only, we have to build a InfiniBand VPN tunnels for data transmission. And these are some scientific research simulation. Already I have told about NASA with the wind tunnel test. The prototype will be placed and they will just simulate the entire environment using the HPC. And this is the main thing. During the COVID, they used the HPC system for inventing the drugs for COVID-19 itself. This is full and full. It's a molecular structure. In the traditional manner, they will just the codes will be running for 5 days, 3 days to get the molecular for a particular model. But using HPC, everything is made fast and for them. How fast the molecules will be. If this molecule is with this person, what will be happened? What will be the output of it? The every output they process and they have made it the entire the COVID-19 vaccine itself through the HPC models only. And for HPC engineering and manufacture, I have told about the Ford systems, Ford Motors, the entire crash test. They are being using the HPC model for the simulating the environment. They cannot just buy a car and make a crash test for all these kind of. For example, we can buy a small car and we can crash test for 1 or 2 cars we can buy and we can crash test. We cannot test the whole thing if it is direct, if it's something hit from the back, something from the left side or the right side on the first of the car. We cannot make the entire thing in the real cars. For that only they have made the simulation models using the HPC systems. And in entertainment media, it is mainly used in Netflix, in Amazon Prime also, mainly for rendering the VFX effects. We are seeing the Hollywood movies and other movie stuffs. the entire VFX, the background VFX, everything. For example, the Marvels movies are there. The entire thing is full and full HPC model. They will just have a blue screen or green screen around the entire thing. The full sets, the background, everything is made in the simulated in the environments. And what is the benefit of HPC in cloud? The thing is we can configure quickly and deploy it for the workloads. And it reduces my time for getting the results. I am getting on demand and it is cost effectiveness. These are the benefits of HPC in the cloud environment. And these case studies we already discussed. And these are another set of case studies, which is Boeing, Sen we have used, Sen I have told, Boeing and Pfizer. These are the two models they are now using. Boeing and Airbus. These are the two aerodynamics company around the world. Boeing and Airbus. They are also doing this simulation environment in HPC, which is cloud-based. They have the cloud in HPC systems. They have the HPC system in a sense. They have the GPU systems installed with the cloud software, and they have created multiple missions, and they are using their simulation environment for that. For that, there is something called bypass. I can directly for a VM, I will assign two processor. That two processor will be pinned in the to the physical process itself, so that the other processor will not get used. And PICE fire for drug. I have told for that COVID-19. That's it. Any questions?
Dear participants, any questions you have?
Sir, good evening, sir.
Good evening, sir. Please, sir.
Good evening, sir. Could you hear me, sir?
Yes, sir. Yes, sir. Loud and clear, sir.
Sir, very basic question. Why we have to go for the mainly the cloud services, even for the small organization and larger organization?
Okay.
May I know the reasons, sir? Main reasons.
For small organization or big organization, that it defines.
Both I am asking, sir.
Okay.
Yeah.
For example, you're having a small organization with 100 members. For that, you are using a development environment or for a ERP solutions. You may heard about the ERP solution. The entire office infrastructure will be handled by that. I think you heard about the company called Zogo. They are the main ERP solution providers. The ERP systems, in a sense, I have assigned a job to you. How long you are doing the job? For that, I have to calculate and put it. I cannot just develop a software for that, else I cannot able to buy a new software and use it. I just go to the cloud, buy it, I will use it. For a minimum organization also, for a big organization also, the same principle. I'm not going to build the whole programs and deploy it. For I will buy it. For deploying, I need a server. For deploying, I need this much big server so that my capital expenditure will be high. The thing here going for that environment is only my operational expenditure will be there. That is the main benefit of going to cloud.
Okay, sir. Thank you, sir.
Any other questions? Thank you, sir. Thanks a lot for sharing your insights and sparing your time. Thanks a lot. It was really very useful for each and every faculties who are connected from various boundaries. Thanks a lot, sir.
Thank you.
Thank you.
And I think most of the persons are faculties.
Yes, sir. All are faculties.
Just I will just give two URLs. It may be useful for them.
Sure,
One
sir.
URL is One URL is Future Skill Prime. That is Ministry of IT upskilling and reskilling program. Here you have paid course and free courses also. This is certified by NASCOM and from Ministry, that your student can able to utilize it. Some courses will be free, some courses you have to pay for it. All the courses are there. And another thing is, you have something called as AICT. You may know about AICT. There is something called as WBL, work-based learning. This is an internship for the students who are studying in the final year or passed out student. AICT will give 6 months training. You have to apply for it. If they select it, you will be posted somewhere across India. Multiple cities. There are multiple cities are there. Look, work-based learning for NEELIT Hyderabad, embedded system, Internet of Things. They will pay 10,000 for you per month. For 6 months, they will pay. These are the two things that so that students can get benefited on this.
Okay. Sure, sir.
Okay, sir. I
Thank
thank
you.
the organizers for this workshop, sir. Looking ahead for you.
Thank you, sir. Thanks a lot, sir.
Thank you, sir.
Dear participants, thanks for your time. Let's end today's session. Let's connect again tomorrow. Thank you all.